In this video, we're going to talk about a reproduction of Eratosthenes' experiment calculating the circumference of the Earth. And specifically, we are looking at two cities that are not on a tropic. Neither of the cities is on a tropic. And because of that, you can see both of these cities are going to cast a shadow. Now, we want to look at why this angle right here that we are calculating based on the right triangle in Salem, Oregon, and this angle, calculated in San Francisco, we want to know why the difference between those two angles is the same as this central angle. And we're going to generalize this actually. We are going to say this could be for any two cities that are not at the tropic. So it doesn't have to be Salem or San Francisco, it could be any cities. And these lines right here are parallel lines. These represent the lines of the rays of the sun. So all of these rays are parallel. The sun is far enough away that we assume that all these rays are going to be parallel. And so these dotted lines just represent those parallel lines. And a way we can mark that is with little parallel marks like this. To prove this, we basically need one theorem. And that theorem is the alternate interior angles theorem, which tells us when we have two parallel lines and what's called a transversal just being a line that crosses both of them, it creates interior angles, that is, angles in between the two parallel lines. And if we look at the alternate interior angles, those are going to be congruent. Or said another way, that means their angle measure will be the same. Now you'll notice we have alternate interior angles over here too that aren't marked. Those would also be equal to each other. And we're just going to present this here without a proof. You can look this proof up separately. We are just going to use this proof now to show that the difference between these two angles and this angle is equivalent. So we did an experiment where we measured the height of this object and the shadow, and we found this angle measure. And maybe we'll mark it by 1 tick mark. And then we did an experiment in a different city and found this angle measure, again by the height of an object and its shadow. These two angle measures were different, so we'll maybe mark that one with 2 tick marks. Now if we consider this parallel line and this parallel line, again representing the sun's rays, and we think about this blue line here as the transversal, then our alternate interior angles will be this one and then this one as well. You see, those are on opposite sides of the transversal and are crossing these two parallel lines. So we'll put a single tick mark in that angle, showing that it matches that one. Now similarly, we are going to consider this parallel line and this parallel line and the transversal of the purple line. So the alternate interior angle here will be this one and this one. But ultimately, the one we want to know is the central angle between these two cities. That's this angle right here. That's the one we're looking for. Well, you can see that these two angles add up to this one. So we could say that the measure of the single tick mark minus the double tick mark is going to equal the angle we're looking for, our central angle between these two cities. So that proves that the difference between these two angles will be equivalent to this central angle right here.